Mass movement. The movement of weathered materials, regolith, down slopes under the force of gravity. A fundamental geological process shaping our landscape. 5 key factors affecting mass movement. Gradient of slope. Steeper slopes accelerate rock material movement compared to gentle slopes. Human activities. Construction, farming, and grazing can promote or reduce material movement. Material nature. Loose materials move faster than tightly held materials. Moisture pressure. Rain, water, and ice act as lubricants promoting downslope movement. Vegetation presence. Plant cover can either increase or decrease rock material movement. Slope gradient, the primary driver. Impact of slope gradient. The inclination of a slope is the paramount determinant of mass movement velocity. Elevated gradients and mountainous terrains significantly accelerate the downslope displacement of geological materials. Fundamental relationship. This direct correlation between the angle of a slope and the speed of material movement establishes a foundational principle for comprehending all geomorphic processes involving mass wasting. Human impact on mass movement. Construction activities. Building on slopes can destabilize materials and alter natural drainage patterns. Agricultural practices. Farming activities can either stabilize slopes through terracing or destabilize through overuse. Grazing impact. Livestock movement on mountain slopes can promote or reduce rock material movement. Material properties matter. Loose materials move faster down slopes due to reduced cohesion between particles. Tightly held materials resist movement due to strong bonds and structural integrity. The heavier the weight of the material, the slower the movement becomes due to increased friction and resistance. Water, nature's lubricant. Moisture as a catalyst. The pressure of lubricating moisture, including rain, water, and ice, acts as a powerful catalyst that promotes and increases the movement of rock materials down slopes. Reduced friction. Water significantly reduces friction between soil and rock particles, making movement easier and more rapid, contributing to landslides and erosion. 2 main types of mass movement. Slow movement. Gradual, often imperceptible movement over long periods. More effective in areas of deep chemical weathering. Fast movement. Rapid, dramatic movement that can occur suddenly and cause immediate landscape changes. Slow movement. 3 key types. Soil creep. Almost unnoticeable continuous movement on gentle slopes, as slow as 1 centimeter per year. Often visible through leaning fence posts or trees. Talus creep. Movement of angular rocks down moderately steep slopes, common in mountain regions. This occurs as individual rock fragments shift gradually over time. Soil flow. Slightly faster movement, averaging 5 centimeters to 1 meter per year on moderate slopes, characterized by visible lobate features in the landscape. Soil creep, the invisible movement, mechanism of movement. Soil creep is the slow, continuous downslope movement of soil and rock particles on gentle slopes, typically as slow as 1 centimeter per year. Water acts as a lubricant, facilitating the movement of rock materials over each other. Influencing factors. This gradual process is significantly influenced by alternating cycles of freezing and thawing, wetting and drying, and heating and cooling. These environmental changes cause expansion and contraction of soil particles, leading to net downslope displacement over time. Signs of soil creep. Tilted structures. Fences, trees, and telegraph poles bend toward the direction of soil movement. Leaning vegetation. Tree trunks lean downslope, and vertical rock layers become tilted. Structural damage. Bulging walls, collapsed fences, and soil accumulation behind barriers. Talus and soil flow. Talus creep, less pervasive than soil creep, involves movement of angular rocks down moderately steep slopes. Large talus sheets move in mountain regions where freeze-thaw action is frequent. Soil flow occurs in temperate and polar regions. During winter, surface layers freeze. In summer, thawed surface soil moves over frozen subsoil. Fast movement types. Fast movement types represent the most dramatic and potentially dangerous forms of mass movement, capable of reshaping landscapes in minutes or hours. Landslides, the most significant. Landslides occur when large quantities of loosened surface rocks and soil suddenly slide down steep slopes, such as cliffs, valley sides, or embankments, caused by water's lubricating action and gravity, often triggered by undercutting at slope bases or human activities. Rock slides and rock falls. Rock slide occurs where rocks have bedding planes slipping toward valleys. Saturated rock layers slide over underlying stable crust on oversteepened slopes. Rock fall, most rapid mass movement on very steep or vertical slopes. Rocks fall vertically to form talus at slope base, triggered by weathering or earthquakes. Earthflow and mudflow. Earthflow characteristics occurs on slopes of 5 to 15 degrees. Regolith becomes water saturated, flows downhill in a viscous manner. Mudflow characteristics occurs on steep slopes, involves semi-liquid mud, gravel, and boulders. Rapid movement due to high water content, common occurrence, prevalent in arid and semi-arid regions, triggered by large volumes of unconsolidated materials. Fluidization by intense rainfall or rapid snowmelt. Effects of mass movement. Agricultural impact. Loss of valuable farmlands and reduced soil fertility affecting food production. Human displacement. Displacement of settlements and communities from affected areas. Infrastructure damage. Disruption of transportation networks including roads, railways, and bridges. Erosion versus mass movement. Key differences. Aspect, definition. Erosion. Gradual movement of topsoil by external agents. Mass movement. Rapid or slow downhill movement of rock and soil due to gravity. Aspect, agents. Erosion. Primarily water, wind, waves, and glaciers. Mass movement. Predominantly the force of gravity, often facilitated by water saturation. Aspect, processes. Erosion. Involves scratching, polishing, pushing, and plucking of material. Mass movement includes processes like creeping, slumping, sliding, and falling. Prevention and management. Vegetation control. Strategic planting of vegetation to stabilize slopes and reduce movement rates. Water management. Proper drainage systems to reduce water saturation and lubricating effects. Engineering solutions. Retaining walls, terracing, and slope modification to prevent mass movement. Global impact and significance. Landscape shaping. Mass movement processes profoundly shape landscapes globally, impacting everything from mountainous terrain to coastal regions. Crucial for urban planning. Understanding these processes is critical for informed urban planning and sustainable development in vulnerable areas. Infrastructure design. Essential knowledge for the strategic design and placement of infrastructure, ensuring stability and safety. Disaster risk reduction. Fundamental in developing strategies for disaster risk reduction and enhancing community resilience against natural hazards. Environmental conservation. Plays a vital role in environmental conservation efforts, protecting ecosystems from rapid degradation and instability. Key takeaways. Gravity rules. Mass movement is fundamentally driven by gravity acting on weathered materials. Multiple factors. Slope gradient, human activities, material properties, moisture, and vegetation all influence movement. Speed varies. Movement ranges from imperceptible soil creep to catastrophic landslides. Human impact. Understanding mass movement is essential for safe development and disaster prevention.